For this quadratic inequality, we need to solve the quadratic equation z squared plus 6z minus 1 is equal to 0 first. That will give us the values of z that will make this polynomial equal to 0. So we'll use the quadratic formula to find these values. Here the quadratic formula is already set up where we plugged in our a, b's, and c's. If we solve that, we get z is equal to negative 3 plus or minus the square root of 10. And the approximate values for these are negative 3 minus the square root of 10 is approximately negative 6.16, and negative 3 plus the square root of 10 is approximately 0.16. Over here we have the number line partitioned into test intervals. The test intervals will be from negative infinity to negative 3 minus the square root of 10, and from negative 3 minus the square root of 10 to negative 3 plus the square root of 10, and from negative 3 plus the square root of 10 to positive infinity. I chose numbers within each one of these test intervals to test. And as I test this first one, which is negative 7, it comes out to be a false statement. So negative 7, when we test it in the original quadratic inequality, it does not come out to be true. If I test 0 in the quadratic inequality, it does come out to be a true statement. If I test 1 in that quadratic inequality, we also get a false statement. So the only time we get a true statement is in the interval between negative 3 minus the square root of 10 and negative 3 plus the square root of 10. So our solution is everything in the interval, including our endpoints, because those endpoints, remember, are those values that actually make it equal to 0. And our original inequality said less than or equal to. So we want to include the endpoints as part of our solution. And if I graph this solution, it's every point in between our endpoints, including our endpoints.